Number 34, find and classify the critical points of this function of two variables. We know we need to take partial derivatives, set them equal to 0. So the partial derivatives are going to be 6x squared minus 6y. And let's see here, minus 6x plus 2y plus 4. And both of these need to equal 0. If we can divide out by 6 in this first equation, and that will give us y is equal to x squared after rearranging. Divide out by 2 in this equation, and that will give us negative 3x plus y plus 2 is equal to 0. So now let's substitute in here. Y is equal to x squared. And this would give us x squared minus 3x plus 2 is equal to 0. This factors nicely as x minus 2 times x minus 1 is equal to 0, which has two solutions here. X is 2 and x is 1. If x is equal to 2, y is 2 squared, y is 4. And if x is equal to 1, y is 1 squared, y is 1. So we have these two critical points here, 2, 4, and 1, 1. Now we need to classify them as saddle points, local mins, local maxes. How do we do that? Okay, well, we know that we need the second order partial derivatives. F sub xx, f sub xy, f sub yy. Okay, so the f sub xx, take the derivative of this with respect to x, will be 12x. F sub xy, take the derivative of this with respect to y. This will give us negative 6. And take the derivative of this with respect to y for f sub yy, that's 2. So our discriminant is f sub xx times f sub yy minus f sub xy squared. And so that's going to be 12x times 2 minus negative 6 squared. So that's going to be 24x minus 36 is our discriminant. Okay, at 1, 1, so let's do this point first here. The discriminant is 24 times 1 minus 36. That is negative 12. That is negative. And so when the discriminant is negative, that tells us that we have a saddle point. And at the point 2, 4, our discriminant D is 24 times 2 minus 36. That's 48 minus 36 is positive 12. So that's positive. So we're in either the local min or the local max case. And to check this, f sub xx is equal to 12 times 2 is 24. That's also positive. So D being positive and f sub xx being positive, this tells us that we are dealing with a local minimum here. So these are the classifications in this problem.